Welcome to this module on quantitative data collection. We're going to dive right in talking about the fundamental principles of analytical design. I was very fortunate to get to hear Edward Tufte speak for his one-day short course. This is one of the things that really jumped out at me. I think it's a really nice way to look at these couple of chapters on quantitative data collection and analysis. Okay, so let's just run through these. I put the chapter from the text from 2006, Beautiful Evidence, that's on these principles of analytical design in your module, as well as a pretty nice size rendering of the Menard graph at the bottom corner there. This is showing the Napoleon march on Russia in this War of 1812. It's really a visceral image, and the chapter walks you through all the analysis. It's really, horrific use, beautiful use of data for a horrific message. Okay, so principle one, comparisons. In science and in analysis, we're showing comparisons of numbers of different factors, which are typically is leading to showing some directionality or causality. Principle three, it's a multivariate world. There are so many factors to consider. Principle four, integration of evidence. You can show your data in formats where there's graphics and annotations all in the same chart. Principle five, documentation. I think this ends with showing your sources, but it starts with how you collect your data and how you treat the fidelity of that data, or how you keep fidelity of that data. Principle six, content counts most of all. This really speaks to what we're doing in our class, is looking at what are important questions. What are the types of questions we're seeking to answer in our research or in the research we're reading. And so if you're not really looking at something meaningful, it's ultimately very hard to save your analysis, right? The content is king principle. So we're going to look at those throughout these presentations. But let's dive right in. Comparisons show comparisons, contrast differences. One of the things with data collection that's so important to consider is sampling. And the goal of quantitative research is typically to show efficacy or to generalize your findings beyond the experiment. And so representative sampling is very important. And the way you sample matters. It has an impact on what you can say about the findings. Okay, so a couple of terms that we've talked a little bit about this previously with quantitative research. You have your population. This is the group of individuals who share these same important characteristics. You have your target population, and this is who we're thinking of when we want to generalize results. And then there may be the accessible or available population. This is who you can realistically get access to from a research perspective. Now, a sample, of course, is the subset of a population, and it's representative or meant to be representative of the accessible population, and so that you can generalize to a larger group. Now, there's many different types of sampling techniques. We're going to talk about some of them. One of the ways to look at it is one type is probability sampling techniques, and this is where another word for it is random sampling techniques, right? This is, we always talk about randomization in rigorous science, and you may be sick of hearing about randomization. What's so important about that? Well, here in sampling, it helps us have better or have a belief that we're getting at a representative set out of the sample. And so it means that all members of a population have an equal chance of being selected for inclusion. And so there's different ways to do randomized sampling. One is a simple random sampling. That's where we just have all available members, could be picked, and then we select randomly. Stratified random sampling, this is where we stratify people into groups and can select out of the group. And so another type is this cluster random sampling. This is where we can cluster people into sets, like such as classrooms or classes, like college classes would be a cluster. And then there could be something called systematic sampling, where we're basically using a random sampling technique, but we might deploy this with certain characteristics attached to it. I'm going to show you a little bit more about that. Just want to look at this stratification concept. I think the random sampling, you get the sense that you pick the number out of a hat, but this one, I think, showing the graphic here, you can see a real nice example in education. You've got a population of 12,000 teachers in a district, and you stratify into two subgroups: elementary teachers and secondary teachers. And then you can sample out of the 4,200 elementary teachers, you got a sample of 175. And out of the 7,800 teachers, you got a sample of 325. So that's the concept of stratification. Now, there's another way to sample, which is non-probability sampling. This is where we don't have that randomization. And sometimes we call this convenience sampling. This is where we only have access to a certain group, and so we sample from that group. We see this a lot in the special education research we do. This concept of snowball sampling is very interesting. The idea is that you recruit people into your study, and they then tell their friends. It basically snowballs. As you get more people, they tell more people, and you get more people in the study. Quota sampling, this may look a lot like quota and purposive sampling. This is where we may do some of that stratification and then be sampling based on our needs for representation of different groupings. So here you see a graphic showing those probability and non-probability sampling techniques. On the biggest picture, I just want you to know that with group designs and with causal correlation or causal comparative designs and correlational designs, this sampling is so vital. The sample sizes, they're going to vary. They must be large enough to provide minimally adequate representation of the larger population. And the sizes definitely depend on the type of quantitative research that you're doing. So this general rule of thumb is something I learned in my research training, that for these randomized clinical trials or this correlational research, you want to have these groups of 15 or 30 is kind of the magic number we always talk about. Some of it's driven by the way the statistics work, that you need a number, and some of it's driven by the expected effect sizes that we see in education. That being said, an important caveat in some of the special education research we do, where we've come up with very impactful interventions and we're looking at serving populations that are in great need, sometimes you can see huge gains and you actually don't need 15 people. There are some really good clinical trials in special ed with 8 people. And I was like, oh, that seems actually pretty doable. Sometimes we have that many people in our single case design. And so not to go off too much on that, but the numbers do matter. There are standards, and it's really good to have consultation from somebody who specializes in statistics or sampling to help you when you're doing this. I know that's the approach I'm taking as I'm stepping into the group design world. Okay, so survey research is another exciting area. I've read the textbook on survey research. I'm a little geeked up on it. I was shocked that with, a very small number, like 300 or 400 participants, you can be getting, if they're truly randomized, you can be getting these representative samples. They're talking about certain percentage of the population, but even in like the U.S., they do these samples, and you think, oh, we need tens of thousands of people. No, with hundreds or even about 1,000 people, you can get very accurate results if it's truly randomized. It's really cool, the science of sampling. Okay, so there's some guidelines for survey research, and this, starting at, if there's 100 people, it's the rule of thumb is you should study the whole population. If it's between 400 and 600, you should sample 50%. If the number of the population is around 1,500, you can go down to 20%. And then this is what I was talking about, that if your population's over 5,000, it's about 400 will be adequate. And it's just remarkable how those numbers work and how those statistics work. The idea, some other terms to think about and be aware of are sampling error. These are the chance variations that are resulting from the lack of representation, and you just don't know where the sampling error may occur. And this sampling bias, when you have a certain way that you're recruiting participants, there may be some fault from the researcher. And sampling bias and sampling error can influence the results. You can certainly see that if you look in politics. If you ask one city versus another, you can see how quickly your data can be skewed. Okay, principle 2, causality. Show causality, mechanism, explanation, and systematic structure. Well, review, I know we introduced this early in the course, the idea of scales of measurement. These are definitely on the test: nominal scale, ordinal scale, interval scale, ratio scale. These are the fundamental ways that we describe the data we collect. So if we want to show causality, it starts with the type of data that we're collecting. And here's a nice table that helps you review what these mean. So nominal, this is, think about it as names, right? The example they show here is, labeling 1 or 2 for gender, if you're talking about binary gender. Or you could really have any gender descriptions that you could just have a written label that describes it. That's just a name, nominal. Ordinal, this is when you're ranking, right? So you think about class rank, that's academic performance rank. First, second, third, fourth, you get the picture. Interval, this is where you may have a test score, and it is in an interval scale, right, where there may or may not be a true zero. If you're at an interval level, actually there's not. It's that there's equal distance between the items, or between the scores. But where we get to ratio, this is where college tuition's the example, and there's a true zero in ratio scale, in ratio data. They use the idea of college tuition, meaning that it could be as little as 0 and it could go up, and it has this similar characteristics to interval scale, and the big difference being that it has a true zero. Okay, so there's a little review. Um, and this data collection really just matches your research questions, and then your aims, and your methodology will guide what type of data you're going to collect. You can make a matrix of aligning questions and data collection strategies. Some of the ways we collect data: surveys, aka questionnaires. We may ask questions of participants. This might be written, it might be online, it can be quick. It could be demographic data, knowledge questions, attitude, behavior. They could be close-ended. You can think about a multiple choice question. Or they could be open-ended, looking for someone's opinion, how they felt about something. They could just write. There can be other formats like checklists, Likert-style questions. You may have a continuum from agree to disagree. And so there's all types of Likert type questions that you can make these scales. In our software Qualtrics, it has a really nice tool where, depending on the question you wrote, it tries to guess the right type of Likert type scale that you want. So why do we have all these methodologies? Well, this concept of principle 3, that it's a multivariate world, the world's complex, and we need to try to reduce some of the complexity through the data we collect. We're trying to put together a analysis, and we want to make sure we are aware of the key things we need to know. When we saw all those survey, data questions, those could just as easily be observation or interview. There's many ways we can collect data. Some of it's driven by efficiency. There's important survey design considerations. You can think about some of these if you need to go deeper. The textbook that I suggest, just ask me for it. I have the tables pulled out. There's some really great resources. Okay, I don't want to get too much into that. This is just a survey of all these methods. It's hard because they're very cool things, and we could probably spend weeks on any one little piece. One way to look at this is right from our teacher training work, is formative and summative. So formative assessments, if you remember, this is what you do during instruction, and this is typically helping you have real-time data for changing our teaching behavior, right? We do that quick check at the end of the lesson to see if we need to keep practicing or if we should be giving just some review, okay? We contrast that with summative assessments. These are thought of as summary results. The way we look at this is after a period of instruction and to inform kind of bigger level moves. So this might be something we do as like a unit exam. We might give a summative assessment like a large scale 3 times a year reading assessment. That might be considered a summative assessment. We may use standardized measures. They may be performance measures, attitudinal measures, behavior measures. And we can collect some of this after the fact. So formative, summative, standardized assessments may already exist. We may also develop our own instruments. We can use an existing instrument. We can adapt an instrument. That happens a ton in research. There's a caveat here to secure permission if it's something that is published and protected by copyright or other sorts of protections. So on a certain level, why do we collect data? Well, we're trying to answer questions, remember? We're making hypotheses. We have burning qualitative questions. And we need to go and seek answers to that. That's what data collection is. So while it's nice, just to bounce back here, it's nice if there is an instrument. That's truly wonderful. But if there isn't, sometimes you have to create your own. So I've been doing that lately. It's pretty fun, but it's a little bit intense. It takes a lot of attention. Although, as I say that, some things might be very straightforward. Okay, so what are the characteristics of quantitative data? Well, this concept of ensuring the quality or the validity of the data, this is fundamental. It's, by definition, the extent to which you measured what you intended to measure. It's really the truthfulness of your data. It's especially important connected to the purposes of your study and the inferences you hope to draw. And we got to look at how you validate your data. So here's some of the sources of validity. This gets into some of the types of validity, like content validity. We can do item sampling and look at the test items to develop a measure of validity for that. There's other types of validity, such as response processes, internal structure, relations to other variables, like this concurrent and predictive validity. This is a little teched out for the purposes of this class. I've studied all this in my PhD training. The main thing I want you to get from this is that there's different types of validity when you go deeper, but they're all really speaking to this truthfulness, this idea that you're measuring what you think you're measuring. How much confidence do we have in that? And there's this complementary concept called reliability. Now, much of this is review for many of you, but this stuff can be tricky, right? Where we're looking at it in a slightly different way. This concept is that it measures the consistency of the data you've collected. So the one that we do a lot in behavior analysis is this idea of inter-rater reliability, meaning that is the rater taking accurate data? We want to have some assurance of that. We do that a lot in single case design. It's actually required of single case design research that meets the quality standards. Another type is test-retest reliability. This could be thought of as stability, and this is where you give an assessment and you want the next administration, if it was right after it, to be stable. You don't want to see a 30 and then a 60 on the test. Wait, which one's actually true? Well, they weren't reliable. So if you don't have that reliable data, it calls into question the validity. And the equivalent forms reliability, this is where for test-retest reliability, it may be very important that those forms are equivalent to get test-retest reliability. There's other types of reliability. I have colleagues who specialize in some of this with survey research and questions and scales. This internal consistency reliability, split half, the Cooter-Richardson and Cronbach's alpha are all examples of that. This is the big picture that I want you to hold on to, is this relationship between validity and reliability. Data can be reliable, meaning that it's stable, but not valid. Data cannot be both valid and unreliable, right? It has to be reliable to be potentially valid, right? And we saw that with the example of if you gave the reading test and they got a 30% and then a 60%, well, it's just not stable enough. If that's out of 100, there's too much variance there. So if it was 30 and 35 and then 30 again, we might go, Okay, that's reliable enough. Now let's look at, are those items or is that measure really showing what we think it's showing? We can look at other aspects of validity, but it's kind of like reliability gets you in the door. It gets you to be able to say that the instrument is performing predictably, right? And a valid test is always reliable, but a reliable test is not always valid, or not necessarily valid. So that's the gist of the relationship. I want to leave you with these items. I hope you enjoy this chapter. It's a pretty light read. I think it'll be enlightening for you around data collection and analysis. And you can see how a multivariate world and circumstance can be boiled down to one graphic and show so much about the ridiculousness and the atrocity that occurred in that example. Okay, thank you very much for listening, everyone.